Hello and welcome. This is the first video for the Year 10 Flip Learning Trial for P3 Forces of Motion, video number 1, calculating speed. And my name is Mr. Clee. Right, the three main things that we're looking for you to get out of watching these videos. The first one is that you're able to define distance, time, average and instantaneous speed and give the units that they're measured in. We're also hoping that you can calculate these things by using and rearranging the speed equals distance over time equation. Finally, we're looking for you to apply these equations to explain how we can use average and instantaneous speed in real life contexts. Firstly, with speed. Speed is one of those situations where you can't actually measure speed directly, it can only be calculated. And you can only calculate it using two values: distance that something travels and the time it takes to travel that distance. For that reason, speed is always measured in a unit such as meters per second, or miles per hour, or kilometers per hour, or meters per minute. It must have a distance component and it must have a time component. That's where the units for speed come from. So the standard unit for calculating speed is in meters per second, because we divide the number of meters that something travels by the time it takes to do so in seconds. Usually this is an example of average speed. So for example, it takes a 100-meter runner 10 seconds to travel the 100-meter distance. Their average speed over this distance is 10 meters per second. However, the speed that they actually travel during this distance will change and will fluctuate. It won't be a constant 10 meters per second. So here is that equation in a form that you can use to rearrange. By using the thumb method, what you can do is cover up one of the units that you want to calculate. So if you want to work out how fast something's going, you cover up speed and that leaves you with distance divided by time. Should you want to work out how far something's gone, cover up the distance, which leaves you with speed times time. And finally, if you want to work out how long something has been travelling for, do the distance divided by the speed. The equation here is a slightly more complicated version of that equation. I'll explain this more on the next slide. Okay, this equation is the simplest version of the first of a number of equations that you might meet called the SUVAT equations. In order to explain what the SUVAT equations show, we need to know what the terms S, U, V, A and T all stand for. Firstly, we'll start with T because it's the most simple one. T stands for time. Acceleration is A. And V stands for velocity, or at least it stands for final velocity in this context. Because V is already taken for velocity, where you've got more than one velocity component, they use U for starting velocity. For the simple reason is that V is next to U in the alphabet. The complicated one comes in with S. Now if, like me, you expect things to make sense in science, you'd hope that S would stand for speed. Unfortunately, S in this case stands for the cryptic displacement, which is just a fancy way of saying distance. Distance can either be, in this case, probably a lateral distance, i.e. how far something's gone, or it can also stand for a height. Translating this to the equation above, what you basically have there is the distance that something travels is equal to its starting speed plus its end speed divided by 2 times by time. This section here is all focused on working out the average speed. So it's the start speed plus the end speed divided by 2, because you're working out an average, times by time gives you distance or displacement, which stands for S. You might want to pause the video here and see if you can work out the answer to this question yourself. What you have to do is work out speed. So you need the distance that Florence Griffith Joyner travels, which is 100 meters, and you need to divide that by the time she took, which was 10.49 seconds. That gives you an average speed of 9.53. Checking your units. The distance was meters, the time was seconds, so the units for speed are meters per second. Here's another example. You might want to pause again, try and give yourself a chance to work this out yourself before I go through the solution. So this is a Formula 1 car. It takes this Ferrari 24 seconds to travel the distance. It starts travelling at 35 meters per second. It ends the straight at 65 meters per second. How long is the straight? First thing to do is to work out the average speed. So you need to do 35 plus 65 divided by 2, which equals 50 meters per second. Put those numbers into the equation. 50 times the time, which is 24 seconds, which gives you a distance of 1,200 meters for this straight. Time was measured in seconds, and speed was measured in meters per second. Therefore, distance must be in meters. This is about as hard as these questions get. Best thing to do in this example is to figure out what you've been given and what you need to work out. First thing, you've been given distance. You've got S as 400, and you'll be given time. You've got T as 4 seconds. Then what you need to do is rearrange this equation. Distance divided by time, 400 over 4, gives you an average speed of 100 meters per second. So that's the first part of the question done. However, what it's asking you here is to see what the top speed is, assuming constant acceleration in this race. What you don't know is that starting speed in a drag race is 0. So if the starting speed in a drag race is 0 and the end speed, or the average speed, is 100, then the end speed must be twice that amount. Therefore 200 meters per second. Final way examiners could try and trip you up, because examiners always like to try and trip you up, is by changing the units that you're expected to calculate speed in, changing the time component or something like that. This question is asking about a train travelling between two Japanese cities that are 515 kilometers apart, taking 1 hour and 43 minutes to do so. The equation that you're going to use is a straightforward one, distance divided by time. The first thing you've got to do, though, is to make sure that you get the distance component correct. Converting 1 hour 43 minutes into a decimal is harder than it might seem. You need to firstly convert 143 into minutes, 103, and divide by the number of minutes in an hour, 60. That gives you a number of hours of 1.72 hours. From that point, it's plain sailing. We're just using distance divided by time again. We've been given distance in the question, 5:15, and we've just worked out time. So 515 divided by 1.72 gives you 299.4, then it's just working out the unit, kilometers per hour. So the summary points for this first video. 1. You cannot measure speed. You can only calculate it by dividing a distance by time. That distance can be really, really small. The time interval can be really small, but it has to be calculated. We can rearrange the speed equals distance over time equation so that you can work out time by dividing distance by speed. You can also rearrange it so you can work out distance by multiplying time and speed together. Also, you can work out average speed, starting speed or end speed by using the first of the SUVAT equations, S equals U plus V over 2 times by T. And that concludes the first video for this trial of flip learning from forces and motion, first video on speed. Please make sure that you do bring the notes that you've made on this video to your first lesson on Wednesday, along with any questions that you might have that have arisen from it. My name is Mr. Clee. Thank you again for watching.